That's what that means. That makes so much more sense now.
He was pissed. He was talking to me on the way. I was going to take you.
I work all
for like
and so I get
32 hours or
11:30 each night. I'm like grinding out the
hours.
that I provide. And then I'm like, oh my God, I have a laptop. I don't know. And I'm like, really? It does. It does.
With so many questions, like, oh, you know. People
This is the worst.
They should be able to understand.
Okay, hope your level of hatred towards instructor and course didn't cross the threshold, and the homework didn't make you completely crazy, or you didn't start it and you don't care yet.
Yeah, I didn't study.
Huh?
I didn't study it. I've been doing other.
Yeah, at least you're honest, man.
Yeah.
But try to start it not on Wednesday morning. Try to do it at least on Tuesday night, so that you can sacrifice sleep or realize that it is undoable or doable is additional time. Just look on it. It's
I'll do it like later tonight or tomorrow. I was just busy with studying.
no, that's fine. Just try to, like computers, load apps into the RAM. Load this homework into your brain. Exactly.
I commit to bed. One thing about me, I commit.
So, Justin, here are your choices, right? And I want to avoid ambiguities. So everything until the next go to the speaker, right? So do not make parallel from line to line. It goes this way.
Scripts.
Right? And what is the goal of or sub goal of these presentations? We all, especially you, like undergrads, are most busiest people in the world. You, as if you also work somewhere and take a lot of credits, just objectively, things may dissolve from the memory. But if your classmate delivers and teaches us some subjects related to our future necessary skills, we can solidify this knowledge. So it is not so much to assess a knowledge of the speaker; it's more to help the rest in the class to assess this, to pick this skill. And if, well, ideally, if someone will not be able to make movies, it will be questions to James, right? And then the rest. If someone will not be able to diagonalize matrices, it will be question to Wyatt.
What? Yeah.
After you talk, you teach everyone how to diagonalize matrices in MATLAB, so that everyone can do it later. It's like not. I haven't designed a way to grade this connection, but it is an ideal goal. Right? So, and scripts is a little extended subject, so it is chopped on sections. So everyone at least happy, or at most happy, and at least not protesting. Okay. With years, I lose confidence in my ability to prepare reasonable slides, and the slides for this meeting are again ugly and extended. I was reviewing them this morning and decided that if I go one slide by slide, the concept will be not communicated, and we will miss time for sure. So what I will try to do an extended summary, which will with guarantee will cover and discuss, and then as time allows, we'll go to details which we will miss anyway. So this equation is something that we do not need to know today. So it is more like a motivation, and we will finish it either coming Wednesday or next Monday, depending on how things are going. But I want to bring it to your attention so that we are progressing through the material with like in a guided way. So you do not feel that someone closed my eyes and leads through the dark forest to some unknown destiny, right? It is the last thing I want you get an impression of. So it's more like with a little flashlight on the clearly paved road. So what? Oh no, I do not like speaking. I like listening. Who have heard about? Thank you. Who have heard about uncertainty principle? Yes, I think he was just first to raise the hand.
I don't know exactly what it is, I just.
Can you roughly about what is uncertain?
I think it's just like where the position of like an electron is at each point. It's just like, it's a relative just unknowns, just kind of testing it with error.
That's great. That's great. James also raised hand.
Like, are we talking about just regular uncertainty or like an uncertainty principle?
Uncertainty principle.
So in regular chemistry, we went over, I think, the Heisenberg uncertainty principle. It's like you can't know both position and velocity of a particle, a subatomic particle, both at once. You know one, but you don't know the other. They're mutually exclusive.
Who agrees? Who disagrees? Who doesn't care or? Okay, so this couple of equations will be our main summary of the long consideration after the finishing or approaching the end of consideration of electron in free space. We should get this equation as a take-home message. So you all agree with Spencer and James, right? At least what they told doesn't offend anyone in intellectual sense. So what are the symbols here? But what? Yes. What do they mean?
Momentum operator and.
Good direction of thinking.
Standard deviation.
Yes. Of what?
The position in the x direction.
Position in the x direction and yes. So product of standard deviation is always bigger than some threshold constant. It means that if they are distributed, you cannot know them simultaneously. It is exactly what Spencer and James were teaching to us. Make sense? It's just in a mathematical sense. Knowledge, if they are probabilistic things, they have standard deviation. If we would know them certainly both at the same time, it would mean their like standard deviation will be approaching zero, and the product will be just bigger than zero, but going to infinite with small value, right? But it is always not just increasing, or it is bigger than a threshold. So one cannot know them simultaneously. And this is Heisenberg uncertainty principle. And here is what we are going to get as a result of our consideration. So we would get in like 2-3 meetings, but since we need to present on MATLAB, likely it will be coming Monday. And we are going to derive both standard deviations as function of time and find out that their product is equal to the threshold constant plus a function that grows quadratically. So no matter what you do, uncertainty will not just bigger than threshold, it will increase for the particle in the free space. It's a like, natural property of quantized particle of the electron, and it is one of the features that we cannot assess intuitively. We need to go through these principles and mathematical derivation And then we get this intuition about quantum objects, and later on in other projects, we can use this intuition to get some conclusions before solving problems. Okay. I would faint if I would be on your side and would see this equation, because it's like too much information, and I don't want to read it line by line. I want someone to guide me through. I don't know what is your impression, but if we get through this equation, it's basically a summary of everything we need to do today. And it's just the best way of summarizing. I just reviewed the notes. If one go step by step with ugly handwriting, it's not possible. 90% of expected result is that everyone gets lost, and we just miss time. So this is almost the answer. It is the latest, second last step before the answer. We need to arrive to the step. What is our goal? What are we, technical goal? What are we doing? This is more linguistic question. Like, if someone here would be not a STEM education track at all, just a person of humanities and linguistics, telling me the second line before the final answer is psi of x of t equal to something. Then the question, what is the technical goal? To find psi of x and t, right? And you agree, right? So we do propagate our model from the past to the future, right? So our initial condition that we know distribution of the past, and through quantum tricks we want to know distribution of this particle in the future. The distribution is wave function squared, right? Absolute value squared. But first we do have equations that allow us to predict the function. You're still following? Close to stop following. Oh, close to stop following. Oh. It is a joke that one of I was witnessing it, and it was both from the friends, and I was seeing it in the class. It's not a surprise that a lot of college lectures are boring, and busy students are just falling asleep after the party, or instructors may wish that falling asleep after doing homework, but
I thought we were just voting on a scale. I didn't.
and here is the joke I was witnessing. So instructor notices that like a third of the class is falling asleep. He just gives a sign to the rest. Raise up, and people woke up and stand up, and you see who was sleeping. So the white boxes top line is what you have successfully got an A grade on the surprise quiz, right? So it's something that one may wish you memorized in the middle of the night, or at least you do not find completely boring, right? So we do combine the eigen-function, eigen-energy, and exponential coefficient in one integral, and the limit from minus infinity to plus infinity. The C sub k is an outcome of your homework. You're strongly recommended to start not before the class, at least the night before, as early as possible. So there is a little trick known from math that definite integral of the second power of exponential is equal to okay,
Square root of pi.
yes, how do you know?
It's a multivariable calculus problem. Basically, you convert to polar coordinates.
So you can derive it
Yeah.
if needed. Anyone else?
It's like Euler's identity, or something like that. I think. I want to say it's like Euler's identity, where it just equal out to
No, there is. I like your direction of thought, but what James verbalized is the closest, or is the right answer. And I do have not the nice, but at least some slides on showing it. It's a very beautiful derivation. If you like math,
I can do it on a board.
that's good. That's good. You like it. You see, there is a volunteer. It's very elegant and it is useful. But in previous years, I was spending like half an hour to make sure that everyone agrees on this statement and missing the main point. Okay, so we do have this integral in the white box, right? And you see that it's integral over variable k, and the variable k comes into the second power, right? So there is a wish, desire, plan, appetite to identify that this white box integral can be converted into this simplified form, to make sure that this integral is equal to square root of pi, right? This is not impossible, but for this procedure, one needs to be sober, not in medical sense, but in a sense that there are little tiny details, and missing them will screw up the result. One can find the answer if it's comparable time. One can find the answer or even the pathway of solution online, or try to do it or combine both. But missing like little sign or factor will make trustability of results substantial. So how can we arrive to this stage? I just need to take a breath and ask someone with a speaking stick. I'm just starting from backwards, from reverse. Kind of any ideas?
How to get to?
Yes.
Well, it looks like you subbed in values for y and then took the derivative back to your dy and then just plug those into your integral to simplify.
That's perfect. I don't know what I'm doing here. I can just. We can do the whole semester just distributing subjects, and you guys will teach each other. It will be more efficient than I'm trying to do here. So one needs to identify the full square, right? So that something, the y squared is such combination of all these powers of exponential that we can make them equal. So technically, the white box is this functional form. So we have quadratic power and linear power. And to make it workable, we need to add minus c multiplied by e plus c. And c, a constant that will allow it to identify a full square. And this there is a way to express it. So if we do this sequence of substitutions, right, then the factor of that is a price for identifying full square is this one. The result of taking Gaussian integral is square root of pi here. And this square root of sigma over A is a result of changing variables. So, no, this pi is also changing variables, but shouldn't be here. It comes after taking the integral. So after taking of the integral, integration variable disappears, and we have only this coefficient that was added as a price for this stuff. But elements of this coefficient are depending on our physical variables that we need to characterize out on space, position in space, and instant of time, right? And it is not an original intention. It is just a consequence of what we are doing, that the factor A contains time and it appears in the denominator of power. So it will be something where the denominator, which controls the width, change over time. Okay? Any objections, questions, protests? Just don't care. So basically, it is what we need to cover, right? And I'll try my best to go over slides and show whatever I can. Let me check. I know that this year we do not watch recordings too much, but it's probably better to, just in case, to first. So it is the answer that I hope to arrive again by going through some details at the end of the class. And the basically it is just covered. And by plugging in this elements, we will get an exponential where the numerator will contain minus x squared. So it will be again a Gaussian exponential. And the denominator will increase imaginary time and imaginary unit and time. But it's a little strange to have some imaginary exponential as an answer. We don't know how to do imaginary distributions, but later on, when we do absolute value squared or conjugated times itself, the distribution will become real and we can analyze it. Okay, so it is the plan. Yep. So this is the answer. And when we were discussing, when we were formulating a problem, we were setting up two hypotheses that we want, or two questions that we want to check: how the center is moving and what width is doing. So I'm not lying, I'm not withdrawing any promises, but it's the question about motion of the center is postponed by 2-3 lectures. It is very doable by this method, but it will be more painful. I do have a shortcut. So right now, let's temporarily assume that initial distribution does have average 0 momentum. So it just steady staying in the origin. It has a Gaussian shape, and we'll explore what happens with the shape. There will be some consequences if we add an average momentum to each point of this distribution, but for simplicity and better organization of effort, it is just I'm inviting you to believe me, at least this time, that it will be more optimal. Okay, so this is the expected last message of the meeting, last slide. If you, okay, and starting from now, basically, if you got the message, you can relax. I will give you a note to wake up if needed, but I'm very dissatisfied with the quality of the slides. If you watch them, just please reduce your standards. So we already discussed this. Okay, so let's. I don't know if I want to say it myself. Maybe James, could you tell us the strategy once again? How do you prove that the integral of e to the minus y squared from minus to plus infinity will be square root of pi?
All right, so it's not integral natively, but if we can put an r next to the e, we can technically integrate it. So what you do is expand it out into itself, e to the negative x squared, make another one, e to the negative y squared, make the dummy variable x and the dummy variable y. So that when you collapse them together, you can form a double integral over R2 to integrate the double variable function. And then when you convert to polar coordinates, the top part, negative x squared plus negative y squared, collapses to negative r squared. And then the Jacobian for polar coordinates goes next to it. You can basically change variables, the r cancels. And when you're converting your limits, it goes from 0 to 2 pi and r goes from 0 to infinity, which basically covers all two dimensions, as opposed to negative infinity x, or basically infinity's x, then infinity's y goes to those limits. Once you do the integral, it comes out to pi, which is what the integral is squared when you make two of it. So you take the square root and it becomes square root of pi. It's very difficult to explain. It's much better read on
No,
board.
it's perfect. It's perfect. And it would take me 15 minutes. You did it in one. So let's thank James. So who can derive this result integration just based on James' explanation? Who certainly cannot derive? Who is may try but without guarantee of success? Okay, but I like his explanation. So here I'm just following strategy of James. So the problem that there is no indefinite integral. If you're thinking about indefinite integral, it is not takeable. There is no answer. There is no answer in standard mathematical functions. One can approximate solution in like series, but then it's too far. But if when it's definite, it's like area under the bell shape. It's definitely a definite value, right? So here's the trick proposed by James. First, we can, by mathematical liberty, we can take this integral twice and multiply these two integrals by each other, right? Then the result will be result of integration squared. Then in one of the integrals, we just swap the variable from y to x. It's still doable, right? Now, if we multiply these two things together, it will be our desired result squared, I capital squared, and it will be e to the power x squared plus y squared. You're following, right? But x squared plus y squared is the distance from the origin. So element of area times e to the power minus distance from origin squared. So it's very elegant, it's nice, but I still don't know how to take it. Right? It still integrals over x and y. And here there is a next strategic trick that James suggested to us. Instead of taking rectangular square element of area, we can take a little like segment of a sector. It's still doable, right? And then the element of area will be length of arc times increment of the distance from the origin. So we do need an element of arc, right? So if the angle is measured in radians, full circle is 2 pi. And what is, if you have a radius r, what is the length of full arc of 2 pi? Yes. And if we have not the full angle, but only a small fraction d phi, what will be the corresponding length?
Fraction of your length is pi.
The size of the angle, d phi times radius. Right?
Yeah.
Agree? If you disagree, you can just show hidden symbol. Everyone agrees? No hidden symbols? Okay. And if one does it, then dr times d phi is arc length. R d phi is arc length. Dr is the thickness, right? The value. You see that originally element of area was dx dy. Here is dr d phi times something additional, right? So it is the price for going from one curvilinear coordinate system to another coordinate system. And James prompted a smart scientific name for this transition.
That's the Jacobian determinant.
So Jacobian determinant, because it is defined in multidimensional spaces as well. So there are well-defined rules how to perform conversion from one curvilinear system to another one. But in this simplest case, it's just R. Okay. Now, if we do this little conversion, is it possible to take the integral? So we do have the exponential, we do have integral over angle, and we do have integral over r. So integral over angle will just give 2 pi, because the rest of the expression under integral does not depend on phi, right? You can just integral d phi from 0 to 2 pi equals 2 pi, a constant. And here we are getting help from the problem itself. So original integral was not takeable because one cannot do any substitutions to do integrals by parts. But here, if you have e minus r squared times r, and then there is a dr, one can include the r inside the differentiation sign, just solve which function upon differentiation will give r. It is r squared. So then we can change integration variable to r squared. And then it will be di squared times e2 minus I r squared. Following? Agreeing? Anyone disagrees? Anyone is not sure? Sure? Sorry. Maybe. Okay. That's basically it, right? you take this integral, and here is what I'm telling. I lost my mood by looking at my old slides, and I'm asking you for a little reduced standards while watching it. Thank you. If you would have 2 hours instead of 1, I would ask one by one to go and do the derivation, and then put it inside the slides. It is what I did before, and then it accumulates from years to years and look this way. But we are replacing integration variables, and then we do have e to the power minus u times du, right? There was a factor 2 because derivative of r squared is 2r, and inversely factor 2. But from integration over angle, we have 2 here, we have 2 there, and they cancel, right? So now we do have integral from, and one another detail. Before in x and y, we were integrating from minus infinity to plus infinity. If we have a polar coordinates, if you have distance from origin and angle, can distance from origin be negative?
It can be negative, but it just reflects the rotation of pi.
Well, technically we can design anything, but it would not make intuitive sense. Like distance from, if you have real distance from origin, then it goes from 0 to infinity, right? Geometrically. And it also changes the limits of integration. And then we have the simplest possible integral, exponential of independent variable over du, right? So integral of exponential is exponential. And then we need to plug in values at upper and lower limits. So what is e at upper limit? What is e to the power minus infinity? Yes. What is e to the power 0? Okay, so we have a leftover pi from integration over angle, and we have 1 just by plugging in the values in the limits. And then the answer is pi. But this was a square of our desired result, right? If you need actual original integral, we need to take square root of it. Okay. Thank you, James. You even with my delay in explanations, it took shorter time. So I did define a full square. I hope no one would oppose to this equation since middle school, right? And the expression in the brackets will be our new independent variable, right? And this a squared and 2ab is what we have here, right? So we need to make connection that this a squared is a squared and 2ab is equal to this one. So we need to redefine a and b in terms of this lowercase and in terms of uppercase. At this point, I will either fall asleep or faint. If you're staying and trying to watch, you're my hearers. Okay, so this term is here. Right? So it's k squared of a squared. This term, it should be 2ab. So if you already defined a in this way, then here is our a. And we need to design such coefficient b that will convert it into the b times k. And just by making equal sign between this b and definition of a, this k times a, we arrive to lowercase b defined this way. This, if you do not protest, it's sufficient, but you can believe it, right? But then to practice our identification of full square, we need to take whatever we define as lowercase b in the second power. So one more exponential with plus and minus sign. So one of them will go into identification of full square, another of them will stay as a free term and finally give us hint to our final answer. So the full square will cancel through this Gaussian integral that gives square root of pi. Okay. Hopefully we will finish this torture in 4 minutes. So basically it is what we did, right? Identified full squared and by mathematical liberty multiplied it by additional term. And then here is the just line by line definition of all steps we are doing. And we are taking this integral and this part goes to the answer. This is the slide that we together observed at the beginning, right? So after change of variables, we want to get square root of pi, and to get the correct answer, we just need to track down what is b squared. So is why do we need to open the slide? Or it is complete byproduct and garbage? So I can answer to myself why I'm looking at the slide and what I'm learning from it. I do want to get that the free term that will contain the answer will include the dependence on time, on position and time. And I'm trying to follow where this dependence on position and time will be included in the answer. This one originates from the wave function. This one originates from eigen-energy. And this one originates from expansion coefficient. Eigen-energy doesn't have k squared because it is already pulled into the integration as integration variable. This eigen-function doesn't have k because it's also pulled into integration. And expansion coefficient that also doesn't have this k squared because we use it. So it's only a coefficient in front of the polynomial. By following this thing and plugging in the values, we are yes, we are arriving to answer. I believe it is more than enough for today. Let's double check if there are questions or points of objection. And notice that 1 minute is returned to your bank of time. So meeting is done. Everyone is welcome to depart and disconnect. But if there are questions, I'll stay here and happy to answer.
Thanks, Gary. Or because we're looking at it online for our lab report.
I just entered mine online.
It's like magic, huh?
Thank you.
I've been working on it.
Oh,
30 seconds.
good. It makes me feel, well, maybe then the next homework will be done in half an hour. Is very optimistic.
I'm hoping.
Okay.
Yeah, let's get it. Yeah, still.
Second assignment is on
Because I wanna go to the two.
when they bring
We have to wait for a stand. I'm going to live.
Well, it's a minimum of 2 hours.
Better get your own real quick.